Hey there, beautiful people. So in this last combined gas law video, I've got a couple more examples for you just in case you're still not getting it. So here we go. I'm going to remind myself of what my combined gas law is. P1 V1 over T1 equals P2 V2 over T2. And I'm going to look to see what I've got. So here we go. When 0.75 milliliters, that's a volume of nitrogen gas at 20 degrees Celsius, that's a temperature, is heated, its volume doubles. What is the new temperature? So technically, this is going to be my V2, and I'm going to come back to that in a second. It says, what is the temperature in Celsius at this new volume? So I have to remember that I have to always convert to kelvins. But in this case, I'm going to convert to kelvins. My answer is going to come out in kelvins, but then I have to come back to Celsius when I'm done for the final answer. So let's plug it in. Now you can see there's no pressures, so my P's are going to cancel out of this formula. So I've got 0.75 milliliters divided by 20 plus 273, which is 293, equals. Now, I have a V2. It tells me that the volume is doubled. Well, if the volume is 0.75, then my new volume, will be 1.50, which is double 0.75. And I'm solving for T2. Cross multiply. So I'm going to get 0.75 T2 equals 1.5 times 20 plus 273. I'm going to divide both sides by 0.75. And I'm going to be left with T2. But remember, my T2 is going to come out in kelvins. So I'm going to change it back at the last second. Here we go. Plug everything into my handy dandy calculator. I've got 1.5 times 20 plus 273 divided by 0.75 equals 586. But that's my kelvins. So to get to kelvins from Celsius, I had to add 273. So to go from kelvins to Celsius, I'm going to subtract 273. So my two answers are 586 and 313. So it comes out to 586 Kelvin minus 273 will give me 313 degrees Celsius. Okay. Now, notice that your T1 was 20 and your T2 was 313, but your volume doubled. Why didn't your temperature double? Well, your temperature did double, but it doubled in kelvins, not in degrees Celsius. So keep that in mind. We always have to work in kelvins whenever we're dealing with gas laws. Let's see one more example. Okay. Remind myself of my formula. P1 V1 over T1 equals P2 V2 over T2. Argon is sealed in a metal canister at a pressure of 1 atmosphere. Oh, there's my P1. And a temperature of 20 degrees Celsius. T1. Over the next hour, the temperature is raised to 50 degrees Celsius. T2. What will be the resulting pressure after this time? Okay, so I've got P's and T's and no V's. So I'm going to cross my V's out like that. So I'm going to plug in 1.0 divided by 20 plus 273 equals P2, because that's what I'm solving for. And then I've got 50 plus 273. Cross multiply. So you're going to have 20 plus 273 times P2 equals 1 times 50 plus 273. Divide both sides by the thing connected to the variable, which is 20 plus 273. I keep wanting to write 21. And my P2 will come out to be, I don't know, let's plug it into the calculator. So I've got 50 plus 273 divided by 20 plus 273, 1.10 ATMs. Now, I double check my digits. I've got 1, 2 digits there, 1, 2 digits there, and 1, 2 digits there. Therefore, I'm going to take that digit off and make it 1.1 atmospheres. How do I know it's atmospheres? It tells me back in the problem. So there's a couple other examples for you for combined gas laws. If you have any questions, drop a comment underneath the video, and I'll be happy to answer it. But otherwise, good luck. Have a great day.